Hello students, welcome to this session. In our previous session, we have discussed Cauchy's integral theorem, Cauchy's integral formula, and we solved some examples. In this session, let us solve some more examples on Cauchy's integral theorem and Cauchy's integral formula. Here, in solving these questions, we have used these formulae. When singular point z equal to a is outside the curve, if pole exists outside the curve, then we have used Cauchy's integral theorem, counter integral of f of z by z minus c dz equal to 0. But when one pole or one singular point is within the curve, then we used Cauchy's integral formula, that is counter integral of fz by z minus a dz equal to 2 pi I f of a. F of a is nothing but value of f of z at z equal to a. But if two singular points or two poles z equal to a and z equal to b, if they lie inside or on the curve, then we have used this formula. This is also Cauchy's integral formula. Here we have to evaluate this one, integral at z equal to a and at z equal to b, then we have to add both. Now, if pole z equal to a is of order 2, then that looks like z minus a whole square in the denominator, then value of this integral is 2 pi I by 1 factorial into f dash of a. Here, by using formula of derivatives, we can find this integral. Then when pole is order of 3, then we have to use this formula, this counter integral of fz by z minus a whole cube, z minus a whole cube dz equal to 2 pi I by 2 factorial f double dash of a. So all these formulae are useful in solving these examples. So let us see examples one by one. Here first one is evaluate. First example is evaluate counter integral e power minus z by z plus 1 dz. E power minus z by z plus 1 dz. Given curve is mod z equal to 1 by 2. This is given curve. So mod z equal to 1 by 2 means this is a circle with center at the origin and radius 1 by 2. Here step 1 is given integral is counter integral of e power minus z by z plus 1 dz. In second step, we find poles by equating denominator to 0. So we can find poles. How? By equating this denominator to 0. What is denominator here? Z plus 1. So here if you equate it to 0, what do you get? Z equal to minus 1. So there is only one pole, Z equal to minus 1. This is the pole. Now what is given curve? Now let us see the given curve. Given curve is mod z equal to half. What does it mean? How do you find its center? If you equate this z to 0, then we get center. So what is z? X plus iy equal to 0 implies x equal to 0, y equal to 0. What does it mean? 0, 0 is the center. 0, 0 is the center. Then how do you get radius? This right hand side number is nothing but radius. So radius equal to 1 by 2. Center is at the origin and radius is 1 by 2. So when you plot that circle like this, here this is the center and here radius is 1 by 2. This is real axis, imaginary axis. Okay, so in next step we have to check whether this pole lies within this circle or outside the circle. What is this? Z equal to minus 1. So here z equal to minus 1, if you plot this, what is this? Minus 1 by 2. So minus 1 is here outside this circle, right? Minus 1 is outside the circle. So z equal to minus 1 lies outside the circle. Outside the circle. If this point or pole lies outside the circle, then we have to use this formula. So contour integral of fz by z minus a dz equal to 0. So whatever that integral may be, that will be equal to 0. So here by Cauchy's integral formula or theorem, by Cauchy's integral theorem, Cauchy's integral theorem. What is given question? Integral e power minus z by z plus 1 dz. This will be equal to 0. Okay. Now let us see next question. Second question. So first we have to find the pole and we have to check whether that pole exists or lies within the given curve or outside the curve. If that point lies outside the given curve, then value of that integral is 0. Now let us see next one. Evaluate contour integral of 2z square plus 5 upon z plus 2 whole cube and z square plus 4. Z plus 2 whole cube and z square plus 4. And given curve is where curve is a rectangle. Here dz is also there. Contour integral of 2z square plus 5 by z plus 2 whole cube into z square plus 4 dz, where curve is a rectangle. Curve is a rectangle with vertices. With vertices 1 plus I, 2 plus I, 2 plus 2I, 1 plus 2I. Okay. These are the vertices of the rectangle. So curve is the rectangle. And here, what is given integral? Given integral is 2z square plus 5 upon z plus 2 whole cube. Here order is 3 and z square plus 4 dz. We have to evaluate this integral. We have to find value of this integral. So first we have to find poles by equating denominator to 0. So here, what is denominator? How do you find these poles? Equate z plus 2 whole cube to 0 and also z square plus 4. Equate this whole denominator to 0. What does it mean? Each bracket will be equal to 0. So z plus 2 whole cube 0 and z square plus 4 equal to 0. Here z plus 2 whole cube means z plus 2 into z plus 2 into z plus 2. This bracket you should write 3 times. Z plus 2 into z plus 2 into z plus 2 equal to 0. And how do you write this? Z square plus 4 means z square plus 2 square equal to 0. Here if you find plus here in the middle implies z square z plus 2i into z minus 2i equal to 0. Okay, we have seen this in our previous lecture. Here if you find plus sign in the middle, then here you should write I, z plus 2i into z minus 2i. Okay, because here a plus bi into a minus bi, what do you get? Which is equal to a square minus abi plus abi minus b square I square. What does it mean? These two terms will get cancelled. We get a square minus b square into I square is minus 1. So what do you get? A square plus b square. So if you find a square plus b square in any question, if you want to factorize that, you can write a plus bi into a minus bi. So here z square plus 2 square is nothing but z plus 2i into z minus 2i. Okay, then what are values of z here? z equal to minus 2i and z equal to 2i. How do you get these values? Again, if you equate each bracket to 0, you get z equal to minus 2i and z equal to plus 2i. That means, what does it mean? Here, z plus 2 we got 3 times. So, z plus 2 equal to 0. Z plus 2 equal to 0. Z plus 2 equal to 0. And here, z plus I equal to 0. Z plus 2i equal to 0. And z minus 2i equal to 0. Z plus 2i equal to 0. Z minus 2i equal to 0. That means here, minus 2i. And here, z equal to 2i. Here, z equal to minus 2. Again here, minus 2, minus 2. Here, what is order? Here, pole of order 3. Z equal to minus 2 is pole of order 3. This one, pole of order 1. Here also order 1. Okay, so after finding these poles, what to do next? Observe the given curve. What is given curve? Given curve is a rectangle. So how do you get that rectangle? Plot that rectangle. What are vertices here? 1 plus I and 2 plus I. 2 plus I. Third one is 2 plus 2i. 1 plus 2i. What does it mean? That means here this means 1 1. This means 2 1. This means 2 2. This is 1 2. 1 plus 2i. 1 plus 2i, that means 1 2. These are the vertices. So using these vertices we can plot a rectangle. So how do you plot a rectangle here? Draw x-axis and y-axis. Here real axis and imaginary axis. Here what is this? 1 1. Let us say 1 2 3 4 5. Here 1 2. Here this point is 1 1. 1 1 means here. This is 1 1. And 2 1. Here 2 1. 2 1. Right. So 1 1 2 1. Then 2 2. 2 2 means here also 2, here also 2 2. Here 1 2 3 4 5. Here 1 2. Right. Then here 1 2 1 2. Okay. So here 1 1. This is a square, not a rectangle. Here 1 1 2 1 2 2. This one is 2 2. This one is 2 1. This one is 1 1. And this one is 1 2. So if you join all these, you get a square. Okay. So here 1 1 2 1 2 2 1 2. These are the vertices of this square. Okay. Now let us plot poles, whatever we got. So what are those poles? Poles are minus 2. Where is minus 2? Here this is minus 1 and here this is minus 2. This is minus 2. And the next one is minus 2i. Minus 2i means 0 minus 2i means here let us say this is minus 1 and minus 2. This is imaginary value. Minus 2i is imaginary value. So you can write minus 2i as 0 minus 2i. What does it mean? Here x value 0, y value minus 2. Okay. So minus 2i means 0 minus 2. Plus 2i means 0 plus 2. Here minus 2i. Let us write that here. Minus 2i means 0 minus 2. And here plus 2i means 0 and plus 2. So 0 minus 2 means this point and 0 plus 2 means this point. So all these 3 points, they are lying outside this closed curve. Okay. So here let us write here z equal to minus 2 and minus 2i and plus 2i. All these three poles, they lie outside the rectangle. Outside the rectangle. If they lie outside this curve, then what is about the integral? Then by Cauchy's integral theorem, what will be value of this? 0. Integral is 0. By Cauchy's integral theorem, f of z by z minus a dz will be equal to 0. That means here counter integral of what is given here, 2z square plus 5 upon z plus 2 whole cube into z square plus 4 dz equal to 0. Third example is evaluate counter integral of 2z plus 1 by z square plus z dz. Here given curve is again mod z equal to 1 by 2. Again it is given circle is given with radius 1 by 2. So here first given integral, we have to evaluate this z square plus z dz equal to what? Find poles. How do you find poles? Equate z square plus z to 0. Equate denominator to 0. Here you can take z common. If you take z common, you get z into z plus 1 equal to 0. What does it mean? This z equal to 0 and z plus 1 equal to 0. Here what does it mean? Z equal to 0 and z plus 1 0. So here z equal to 0 and z equal to minus 1 are poles. So after finding poles, we have to plot the given curve. What is this given curve? Given curve mod z equal to half is a circle. Already we have seen in our previous example. Curve is a circle with center at the origin and radius 1 by 2. So if you plot that circle, let us plot that circle. Here this is 1 by 2, radius 1 by 2. Right. Then what are poles here? 0 and minus 1. This is minus 1 by 2. And let us say minus 1 is here. So this is one pole and this is one pole. Right. So one singular point is lying within this curve and one point outside the curve. What is that? Here z equal to 0 is lying within this curve, within the circle, and z equal to minus 1 is lying outside the curve. So here we have to apply two formulae, Cauchy's integral theorem and Cauchy's integral formula. Okay, let us see those. So here z equal to 0. So first let us say z equal to minus 1. Let us take z equal to minus 1. Lies outside the circle. Outside the circle. Then by Cauchy's integral theorem. Cauchy's integral theorem. F of z by z minus a dz equal to 0. So here at z equal to minus 1 and z equal to minus 1, counter integral of what is this? 2z plus 1 by z square plus z dz will be 0 at this point. Now let us take second point. What is that? Z equal to 0. Z equal to 0 lies within the circle or inside the circle. Lies inside the circle. if any point lies inside the circle, then we use Cauchy's integral formula. So by Cauchy's integral formula, what is that Cauchy's integral formula? By Cauchy's integral formula, counter integral of fz by z minus a dz equal to 2 pi I into f of a. We use this. What does this mean? F of a. F of a means value of f of z at z equal to a. Okay, so we have to use this formula for this point z equal to 0. So let us write this integral. What is this? 2z plus 1. 2z plus 1 by here z square plus z dz, which is equal to, here see, we can write this as 2z plus 1 by integral of 2z plus 1 z into z plus 1 dz, right? Now here we are considering the pole z equal to 0, right? So here take this z plus 1 in the numerator. So we can write this as 2z plus 1 by z plus 1 upon z dz. Okay, upon z means here this z minus 0. This can be written as z minus 0. Okay, understood this? Here, see, first we have written factors of z square plus z. After writing these factors, whatever the pole we are finding the integral for the pole z equal to 0, right? So the term z minus a, if you find this integral for the pole z equal to a, then z equal to a should be in the denominator. So here we are finding for z equal to 0. So z should be in the denominator and all the remaining terms we write in numerator. Okay, then here that is equal to integral of 2z plus 1 upon z plus 1. Here this one is nothing but f of z upon z minus 0 dz. We can write z as z minus 0 dz. So what is this? This is in the form of z minus a, right? So here implies a equal to, if you compare these two, what is the value of a? 0. Okay, so z equal to 0. So here value of a is 0. So in that formula, put a equal here. What is that formula? Integral f of z by z minus a dz equal to 2 pi I into f of a. We have to find value of f z at a equal to 0. So according to that formula, here 2 pi I into f of z. What is f of z here? 2z plus 1 by z plus 1. This one is f of z. We have to find its value at z equal to 0. At z equal to a. Z equal to a means z equal to 0 here. Okay. Now 2 pi I, if you put z equal to 0, 2 into 0 plus 1 upon 0 plus 1, which is equal to 2 pi I. Now the value of the integral 2z plus 1 upon z square plus z, or let us write z into z plus 1, z into z plus 1 dz equal to, this is along curve C. So here along C1, first we have taken this integral upon z by z plus 1, right? Because we have evaluated the value of the integral for the pole z equal to minus 1 first, plus along the curve C2, 2z plus 1 by z plus 1 upon z dz. So value of this integral is 0, which is equal to value of first integral is 0, and value of the second integral we got 2 pi I. So 0 plus 2 pi I, which is equal to 2 pi I. So value of this integral is 2 pi I. So if you find more than one singular points, you have to find values of the integral at all those points, then we have to add. Now let us see next example. Example number 4. Evaluate z square plus 5, quarter integral of z square plus 5 by z minus 3 dz, where curve is here more than one curve are given, that is mod z equal to 4 and second one mod z equal to 1. Here two circles are given, so we have to find value of this integral separately for both the circles. So here let us solve for this circle mod z equal to 4. Now we have to evaluate value of this integral for this one, mod z equal to 4. So first we have to find poles by equating denominator to 0. Here only one pole is there, z minus 3 equal to 0, that means z equal to 3. Z equal to 3 is the pole. After finding pole, we have to plot this curve. What is this curve? Mod z equal to 4 means implies circle with center. If you find only z within this mod, that means center is origin only. Okay, with center 0 0 and right side number indicates radius and radius 4. Okay, so if you plot this, here this one is 4, radius is 4. If radius is 4, here pole is 3, that means here 1 2 3 4, so 3 lies within this circle. 1 2 3. Okay, 3 lies within this circle. So we have to use Cauchy's integral formula to evaluate this integral. Here only one pole is there, so we have to apply only one that formula only once. So here z equal to 3 lies within the circle. What is that circle? Mod z equal to 4. Right. Therefore, by Cauchy's integral formula, what is that formula? Counter integral of fz by z minus a dz equal to 2 pi I f of a into f of a. So here counter integration of z square plus 5 by z minus 3 dz. So here this one z square plus 5 is f of z. If you compare this with counter integral f of z by z minus a dz, what do you observe? Here value of a is 3 and this one is f of z. So here f of z equal to z square plus 5. Okay, and z equal to a, that is a equal to 3. A equal to 3. Okay, if a equal to 3 implies f of a equal to, if you replace z by 3, then you get 3 square plus 5. Because f of a is nothing but a square plus 5, which is equal to 3 square plus 5. Okay, so without comparison directly, if you put z equal to 3, it's okay. Here I am comparing this and explaining. So here consider this numerator as f of z and put z equal to 3 in this numerator. That means what do you get? 9 plus 5, which is equal to 14. Then here value of this integral z square plus 5 by z minus 3 dz equal to 2 pi I into 14, because here f of a is 14. So we get 2 pi I into 14, which is equal to 28 pi I. This is the solution of this question. Now let us see one more question. Fifth one. Evaluate. In this question only one more circle is there, right? The second question is there, B. What is that? Mod z equal to 1. Mod z equal to 1 means circle with center. Circle with center 0, 0 and radius 1. So if you plot this again, here this is 1, radius is 1, but our pole, what is that pole? Pole is 3. 1, 2, 3. Here this one is the pole. So pole is existing outside the circle now. Here z equal to 3 lies outside the circle. Outside the circle. Then by Cauchy's theorem. By Cauchy's integral theorem. What do you get? Counter integral of fz by z minus a dz is 0. Therefore, counter integral of z square plus 5 upon z minus 3 dz is 0. So, in our previous circle, that is mod z equal to 4, we have used Cauchy's integral formula because the 3 lies within the circle mod z equal to 4. Here, within this circle mod z equal to 4, this 3 is lying here. That's why we have used Cauchy's integral formula. But here, this point is outside the circle. That's why we have used Cauchy's integral theorem. Then this integral becomes 0. Now, let us see next question. Evaluate. Evaluate counter integral of e power z by z minus 2 dz. E power z by z minus 2 dz, where C is a circle, mod z equal to 3, and this is one question, and other one is mod z equal to 1. Here also two circles are provided. We have to solve for both. So here let us consider first one. First you have to find poles for this one. How do you find poles? By equating denominator to 0. Equate this to 0. So z minus 2 equal to 0 implies z equal to 2 is a pole. Z equal to 2 is a pole. After finding pole, what to do? We have to draw this circle. What is that circle? Here curve is mod z equal to 3. What does it mean? Here if you find only z, what does it mean? This is a circle. Circle with center 0, 0 and radius 3. Right side number indicates radius. Then plot this circle. If you plot this circle, here 1, 2, 3, radius is 3. X-axis, real axis and imaginary axis. So here z equal to 2 lies inside this curve inside the circle, right? So if this lies inside the circle, so here z equal to 2 lies inside the circle mod z equal to 3. So we have to apply Cauchy's integral formula. Cauchy's integral formula. What is that formula? Counter integral of fz by z minus a dz equal to 2 pi I into f of a. So, counter integral of e power z by z minus 2 dz equal to 2 pi I. Here, what is f of z here? This one is f of z. Okay, and this one is a. So, here put z equal to 2. That's all. Here f of z equal to e power z. And f of a means what? E power a. But a equal to 2 here. So, f of a equal to, what do you get? F of a equal to e square. So, or simply you put z equal to, here whatever number is there, put in the place of z. Okay, where? In the numerator. So here 2 pi I into e square. This is value of the integral. Now what is second one? Second curve is mod z equal to 1. What is mod z equal to 1? Circle with center 0, 0 and radius 1. Okay, if you plot this, here this is 1, radius 1. But what is our pole? Pole is z equal to 2. So here z equal to 2 lies outside the circle. So here z equal to 2 lies outside the circle mod z equal to 1. Then by Cauchy's integral theorem, value of this integral is 0. Fz by z minus a dz is 0. Therefore, counter integral e power z by z minus 2 dz is 0. Next one is evaluate counter integral of z square dz equal to 0, where curve is mod z equal to 1. Here if you observe, denominator is 1 here. Mod z here z square dz means z square upon 1 dz, right? So here what does it mean? Z square by 1 dz. Evaluate z square dz not equal to 0. Evaluate counter integral of z square dz, where curve is mod z equal to 1. So here denominator is 1. What does it mean? If denominator is 1, there are no poles. Here denominator is 1 implies no poles. No poles means if there is any region, what is this curve? Circle with radius 1. Mod z equal to 1 means circle with radius 1. So here no poles means there are no singular points within this region. If there are no singular points, what does it mean? Fz, this given function is analytic within this closed curve. If Fz is analytic within this closed curve, then by Cauchy's integral theorem, value of this integral is 0. So here If there are no poles, here no poles within the curve. Okay. If there are no singular points within the curve, what does it mean? Within the curve means fz is analytic. Fz is analytic at every point. At every point within the curve. If fz is analytic at every point within the curve, then by Cauchy's integral theorem, integral fz dz is 0. Okay, it may be fz or maybe fz by z minus a. So here this is 0. Therefore, our given integral z square dz is, value of this integral is 0. Now let us see one more example, last example. Evaluate dz by z square minus 1, where c is x square plus y square equal to 4. Here equation of the circle is directly given in terms of xy, right? So here first we have to evaluate this integral. Which integral? Dz by z square minus 1 dz dz by z square minus 1. So in first step we have written this integral. Then find poles. How do we find poles? By equating denominator to 0. So here equate z square minus 1 to 0. So here z square minus 1 means z plus 1 into z minus 1 equal to 0. Here we have applied a square minus b square formula. A plus b into a minus b. Here z square minus 1 can be written as z square minus 1 square, right? So we have applied that. So here z plus 1 equal to 0 and z minus 1 equal to 0. What does it mean? Z equal to minus 1 and plus 1. So there are two poles. These are the poles. Poles are z equal to minus 1 and z equal to plus 1. Now let us plot this circle. What is given curve? Given curve is x square plus y square equal to 4. So this is the equation of a circle. So you can write it as x square plus y square equal to 2 square. So this is circle with center 0, 0 at origin and radius 2. Okay, so here if we consider circle like this, we have to take this number as it is. We have to consider this as it is, as a radius. Because here mod z means the square root of x square plus y square. So after squaring this on both sides, we get such type of equation. Okay, so if you consider circle equation in this manner, consider this number as a radius. But if you find x square plus y square equal to some number, then write that number as a perfect square. Here 4 2 square, and consider the number within the bracket as radius. So here radius is 2. Now here what are our poles? Poles are minus 1 and plus 1, right? So if we plot this circle with radius 2, 0. So here 1 minus 1, both these points they are lying inside this circle. Both these points are lying inside the circle. So here z equal to minus 1 and z equal to plus 1, they lie inside circle x square plus y square equal to 4. Okay, then we can write this. What is this? dz by z square minus 1. How do you write this? Which is equal to, write factors in the denominator. What are factors of z square minus 1? Z plus 1 into z minus 1. Okay, this is along curve C. Then we can write it as along curve C1. Here dz by z minus 1 upon z plus 1, or you can write 1 by z minus 1 upon z plus 1 dz, plus along curve C2 1 by z plus 1 upon z minus 1 dz. Then we have to use this formula. Which formula? Here, counter integral along C, fz by z minus a into z minus b. We have discussed this point, this formula. So how do you write this? What is this? Counter integral along C1, fz by z minus b upon z minus a dz, plus counter integral along C2, fz by z minus a upon z minus b dz. Then according to this formula, what do you get here? Which is equal to 2 pi I, here f of z by z minus b at z equal to a, plus 2 pi I f of z by z minus a at z equal to b. We have to apply this formula. So here this integral can be written as C, here dz by z minus 1 or z plus 1 into z minus 1 can be written as, we have written it, again let us write it. Here 1 by z minus 1 upon z plus 1 dz, plus 1 by z plus 1 upon z minus 1 dz. So which is equal to 2 pi I into whatever is in the numerator, write it here, z minus 1. Then here z equal to, here z plus 1 is there in the denominator, right? If you equate this denominator to 0, what do you get? Z equal to minus 1. So here put z equal to minus 1. Plus again 2 pi I. Write the term which is in the numerator. So 1 by z plus 1. 1 by z plus 1. Then here equate this to 0, implies z equal to 1. Here implies z equal to minus 1. Okay, so here you should write z equal to 1. Now evaluate. That means put z equal to minus 1. 1 by minus 1 plus 2 pi I. Here 1 by 1 plus 1. Then what do you get? 2 pi I into 1 by minus 2 plus 2 pi I into 1 by 2. So here 2 will get cancelled. Here minus 2 plus 2 cancelled. Then you get minus pi I plus pi I. Minus pi I and plus pi I, which is equal to 0. So value of this integral is 0. Next question is evaluate counter integral 4 minus 3z by z into z minus 1 into z minus 2 dz, where curve is mod z equal to 3 by 2. So here first we have to find poles by equating this denominator to 0. If we equate this denominator to 0, here we get z into z minus 1 into z minus 2 equal to 0. That means each term becomes 0. Z equal to 0 and z minus 1 becomes 0 and z minus 2 equal to 0. So here z equal to 0 and z equal to 1, z equal to 2. These three numbers are poles, 3 points are poles or singularities. Now given curve is mod z equal to 3 by 2. Curve is mod z equal to 3 by 2. What does it mean? Mod z equal to 3 by 2 means here z equal to 0, 0. Here is 0, 0 is the center and this number, this is radius. Radius equal to 3 by 2. That means 1.5. So let us plot this circle with center 0, 0 and radius 1.5. Okay, now let us check whether these poles they lie inside the circle or outside the circle. So here let us say this is 1 and this point is 2. Now our poles are 0, 1 and 2. So 2 points they are lying within the circle and 1 point is outside the circle. So here z equal to 0, z equal to 0 and z equal to 1 lie inside the circle and z equal to 2 outside the circle. Now let us evaluate the integral. We can write this integral 4 minus 3z by z into z minus 1 into z minus 2 dz as along C1. Here if we consider the pole z equal to 0, then while writing this integral z comes in the denominator. When we are considering second pole z equal to 1, then z into z minus 2 comes in the numerator. They come in the numerator and z minus 1 comes in the denominator. Plus third one is C3, 4 minus 3z by z into z minus 1. Third pole is z equal to 2. So z minus 2 we should write in the denominator. Right. So when we observe, this is inside the circle. This one inside the circle. But this one outside the circle. Z equal to 2 outside. Here inside. What is this? Z equal to 1. Here this is Z equal to 0. Right. So these two poles they are lying inside the circle and this is outside the circle. When this is outside the circle, when the point lies outside the circle, then value of that integral is 0. So here if point is inside the circle, then 2 pi I into the term which is in the numerator 4 minus 3z by z minus 1 into z minus 2, then write the pole. What is that? Z equal to 0. Okay, plus 2 pi I, then write the term which is in the numerator. What is that? 4 minus 3z by z into z minus 2. Then what is the pole? Z equal to 1. So we have to find value of this bracket, the terms which are in the bracket at z equal to 1. Now what is the value of third integral? 0, because z equal to 2 is lying outside the circle. Now let us simplify. So what do we get? Here 2 pi I 4 minus 3 into 0 upon 0 minus 1 into 0 minus 2. Put z equal to 0. Plus 2 pi I. Here put z equal to 1. So 4 minus 3 into 1 upon 1 into 1 minus 2. So what do you get here? 2 pi I into, here this is 4 by 2. 4 by 2 plus 2 pi I into here 1 by minus 1. What does it mean? Which is equal to 4 pi I minus 2 pi I, that gives 2 pi I, which is the solution of this integral. Okay, so let us see ninth question. Ninth question is evaluate counter integral of 3z square plus z upon z square minus 1 dz where curve is mod of z minus 1 equal to 1 here. So here in this solution, first let us find poles. Here, how do you find poles? By equating denominator to 0. We can get poles or singular points. So equate z square minus 1 to 0. So you can write this as z plus 1 into z minus 1 by a square minus b square identity. So here z plus 1 equal to 0, z minus 1 equal to 0. So z equal to minus 1 and plus 1 are poles. We get two poles here. What are they? Z equal to minus 1 and z equal to plus 1. Now let us check this given circle. What is given here? Here circle is, curve is mod z minus 1 equal to 1. What is this? Circle with center 1 0 and radius 1. So how do you get this center? Here see this, equate this to 0, z minus 1 equal to 0. So z equal to 1 implies x plus iy equal to 1 plus I 0. So this is value of x, 1 is value of x and 0 is value of y. Implies x equal to 1, y equal to 0 is the center. Now let us plot that circle. Here center is 1 0, 1 0. On x-axis value of y is 0. So this is point 1 0, this is the center. You get circle like this. Okay. So let us check these points. Here z equal to 1 lies within the circle and z equal to minus 1 lies outside the circle. So let us write this integral first. 3z square plus z upon z plus 1 into z minus 1 dz equal to, let us write this integral as counter integral along C1, 3z square plus z upon z minus 1 by z plus 1 dz plus counter integral C2, 3z square plus z upon z plus 1 upon z minus 1 dz. Okay. Now if you see here, this is nothing but pole z equal to minus 1. Here z equal to 1. Okay. So z equal to minus 1 lies outside the circle. Here z equal to 1 inside. So here you have to apply Cauchy's integral theorem. Cauchy's theorem. Here Cauchy's formula. Okay, what is this Cauchy's theorem? Counter integral fz by z minus a dz equal to 0. We have to apply this here. And here counter integral fz by z minus a dz equal to 2 pi I into f of a. So we have to apply these formulae. So according to these, value of first integral is 0. Here value of the second integral 2 pi I into, here what is f of z? F of z is nothing but the expression which is in the numerator. So here 3z square plus z upon z plus 1. This is f of z. We have to find its value at z equal to, at z equal to plus 1. Because pole is z equal to 1. Okay. Which is equal to 2 pi I into Here 3 into 1 plus 1 upon 1 plus 1. So what do you get? 2 pi I into 4 by 2. So which is equal to 4 pi I. This is solution of this question. Next question is 10th question. Evaluate counter integral C z plus 4 by z square plus 2z plus 5 dz, and curve is along the curve is modulus of z plus 1 minus I equal to, okay, so here first we have to find poles. Z square plus 2z plus 5 dz. So to find poles, equate this denominator to 0. What is denominator here? Z square plus 2z plus 5 equal to 0. Here we can't factorize this directly. So use formula method to find value of z. Minus b plus or minus square root of b square minus 4ac upon 2a upon 2 into 1. So what do you get here? Minus 2 plus or minus 4 minus 20 minus 16 upon 2. That is minus 2 plus or minus 4i upon 2, which is equal to minus 1 plus or minus 2i. So these are the poles. So poles are z equal to minus 1 plus 2i and minus 1 minus 2i are poles. Okay, here we have applied this formula. Ax square plus bx plus c equal to 0. Then x equal to minus b plus or minus square root of b square minus 4ac by 2a. Using this formula, we can find root. So here root is this value of z we can find. Now, let us see this circle. What is given? Modulus of z plus 1 minus I equal to 2 is the circle. So how do you find center? To find center, equate this to 0. So here z plus 1 minus I equal to 0. Whatever term may be in this modulus, equate it to 0. So what do you get? Z equal to minus 1 plus I. Plus I means minus 1 plus I into 1. So here this is similar to x plus iy. X plus iy. If you compare this, x equal to minus 1, y equal to 1. So here center is the center, circle with center minus 1 1 and radius 2. So if we plot this, here 1, 2, 3, 4, so on. Here minus 1, minus 2, minus 3, so on. Here 1, 2, 3. So here center is minus 1, 1. That means this one is the center. Minus 1, 1 is the center. And here radius is 2. So here 1, 2. Radius is here at this 3. And here consider here up to this axis it is 1. And here up to minus 1. Radius 2 means. And here it is 1 up to here. Here 1, here. So if you join all these, you get a circle. Like this, okay. So this is the center. Now what are the points? This is minus 1, 1, center. Okay, what are poles? Poles are minus 1 plus 2i, minus 1 minus 2i. Right? So here minus 1 plus 2i implies minus 1 plus 2 in the form of ordered pair. Minus 1 minus 2i means x value is minus 1, y value is minus 2. Minus 1 plus 2i means x value is minus 1, y value is 2. So here x is minus 1, y is plus 2. That means here, what is this? Minus 1 plus 2i. Okay, next point is minus 1 minus 2i. Minus 1 minus 2. This is minus 1 minus 2i. So one point is lying inside and one pole is lying outside. So here z equal to minus 1 plus 2i lies inside and z equal to minus 1 minus 2i lies outside the circle. So if we write the integral, counter integral of c, then here z plus 4 by z square plus 2z plus 5 dz equal to, here along C1 z plus 4 by, here what are these factors? Factors of this z square plus 2z plus 5. Here we got z equal to minus 1 plus or minus 2i, right? Minus 1 plus 2i. That means here z plus 1 minus 2i. This is one factor. And other factor is z here minus 1 minus 2i. So here z plus 1 plus 2i. These are the factors. That means here you can write this expression as z plus 1 minus 2i. Then here z plus 1 plus 2i dz. Let us write this first. Then which is equal to, here let us split it. So along curve C1, here z plus 4 by z plus 4 by z plus 1 plus 2i upon z plus 1 minus 2i dz, plus along C2, z plus 4 by, here z plus 1 plus minus 2i plus 1 minus 2i upon z plus 1 plus 2i dz. Okay, now if you observe this one, what is this here? What is value of z? Z equal to minus 1 plus 2i, right? Z equal to minus 1 plus 2i. That means here lies inside. And here what is this? Z equal to minus 1 minus 2i. So minus 1 minus 2i lies outside. If it is lying outside, its value is 0. Directly we can write 0. But if it is lying inside, then we have to find its value. How? 2 pi I into this numerator, z plus 4 by z plus 1 plus 2i. We have to find value of this at z equal to minus 1 plus 2i. Okay, so let us find its value. Here plus 0, which is equal to 2 pi I. Then here put z equal to minus 1 plus 2i. So minus 1 plus 2i plus 4 upon minus 1 plus 2i plus 4 minus 1 plus 2i plus 1 plus 2i plus 2i. So what do we get here? We get here minus 1 plus 1 will get cancelled. So here 2 pi I into, here 4 minus 1 3. So 3 plus 2i upon 4i. So here I will get cancelled. So final answer is It is very congested here. Let us see. Which is equal to 5 by 2 into 3 plus 2y. This is the solution of this question. So let us see some more questions in next session. Thank you. Value of this integral is 0.